Algebra 1, final exam number 2 review. So let's go ahead and jump into it. Here in our first question, they're asking us to find an expression that is equivalent to this. So essentially, what I'm getting from this is that we need a greatest common factor. We want to find whatever it has in common. Now, I'll go ahead and just work this one. I see that these guys both have a 7 in common, so I'll take a 7 out. I see that there's a negative in front of my leading coefficient, so I'll take that out as well. And I see they both have at least one x. Now I'm going to go through and I'll divide everything by negative 7x. And I end up with a more simplified expression. Number 2. The graph shows the height in feet of an object above the ground t seconds after it was launched from the ground. What is the function best represented by the graph in this situation? So here they're asking me to go ahead and run a regression. So I'll go ahead, I'll find a few really good points. And I'll go ahead and put them into a table. Remembering how these points should be mirrored. So notice we have 0, 48, 64, 48, 0. So this is going to be my maximum. Now I'm going to go ahead and swing over to my calculator. I'm going to go ahead and run that regression. I'll go ahead and run my quadratic regression. And here's my equation. Negative 16x squared plus 64x. Number 3, in a sequence of numbers, these are there. 3, 0, 4, 6, 5, 12, 6, 18, 7, 24. Based on this information, which equation can be used to find the nth term in the sequence? Okay, so first thing I want to do is I want to go ahead and rearrange these. Now I'm going to analyze this pattern. I see plus 6, plus 6, plus 6, plus 6. So that tells me that D, the common difference, is plus 6. And as you remember, we always have to first find what would be the very first term in the sequence. So if I go back 6, negative 12 would be A sub 1. So that means that A sub n is going to be equal to negative 12 plus 6 times n minus 1. They could ask us to simplify this, in which case I would go ahead and just simplify it to the best of my abilities, and I would end up with something that looks like y equals mx plus b. I could have also ran a linear regression because this was an arithmetic sequence. Which means it's linear. Alright, next one, number 4. Which graph best represents a system of equations that has no solution? No solution. So whenever I hear no solution, I think parallel, and they don't touch. These guys are touching. These will eventually touch. That one's touching. These are the only parallel ones. So that means that this is going to be the only one that has no solution. Next one. What value of n makes this equation true? So I could use an n-solve in the calculator, but I'm going to go ahead and solve this one by hand. So I'm going to first go ahead and distribute. Actually, I'd really like to get rid of that because that's really ugly. But if we distribute it, it would come out evenly. So 4 times 0.5. Now I can go ahead and combine like terms. Now I'm going to go ahead and get all of my n's together. Now I'm going to go ahead and add 3 to both sides. And I end up with n equals -9. Next one. The value of y varies directly with x. As soon as I hear that, this is what I think. So they said if x is equal to 3, y is equal to 21, what is the value of x when y is 105? Now I can go ahead and cross multiply. And of course divide by my coefficient in order to get x by itself. And I find out that my x value will be 15. Next one. They want us to go ahead and factor this. So first thing I'm going to do is I'm going to multiply a times c. I need two numbers that will multiply together will give me that. However, they need to add together to give me -17. I imagine that this is one negative, one positive. So I'll say -1, positive 60. No. So -2, positive 30. No. -3, positive 20. That's positive 17. So I'll go ahead and flip those around. And we end up with our two values. Now I'll go ahead and split apart my b value. Now I'll factor out from just the first set and factor out from just the second set. I'm going to verify that the insides are the same, and they are. Now I can combine like terms, and we are completely factored. Next one. Here they're asking me about this particular equation. Now, this is one of the actual questions. Hold on, let's see. This is one of the actual questions from your final exam. Let me find it. So they're asking us about zeros and factoring. So you want to find your factors and your zeros. So first thing, I see here that this is a really big number. But if I set this equal to 0 in order to find my zeros, I can move that 576 over. Then I can take the square root of both sides, and I'll get my two zeros. And I find out that x is equal to plus or minus 24, meaning I have one that looks like this and one that looks like this. This is also the difference of perfect squares. The difference of perfect squares, okay? So lots of different ways to solve this. We could have went traditional factoring. We could have done difference of perfect squares. We could have also done what I did, which is using the method involving radicals. All right, next one. What appears to be the domain of the exponential function graphed in the grid below. So they are asking me about domain. So whenever I hear domain, I immediately say, okay, I need to deal with my x's. I see that this is a continuous function, so I'm going to write this out. I see it starts at -1, the dot is filled in. I see it goes all the way up to +3, the dot is filled in. Here is my domain. I'm done. Next one. Two customers went to a post office to buy postcards in large envelopes. Each postcard costs the same amount. Each large envelope costs the same amount. The first customer paid $12 for 14 postcards and 5 large envelopes. And the second customer paid $24.80 for 10 postcards and 15 large envelopes. And they want to know the cost of the large envelopes. So I've already gotten my equations because I translated these. So I'll go ahead and I'll run a LinSolve. I'm going to rename these as P and L. And it looks like each postcard is 35 cents. And my large envelopes cost $1.42. Next one. Here they're asking me to find solutions. So this is kind of a weird problem. I could multiply this out, do traditional factoring, do the quadratic equation. I could do a lot of different things. But we're going to use radicals because that's going to be the easiest in this situation. Now I ended up here. I'm going to move this 7 over. And now I just have to split it apart. And I end up with my two solutions. Pretty simple and easy. Next one. So here they want me to simplify this. So first thing I want to do is I want to get all my x's together, but they need to be on that left side. Now I'm going to go ahead and start my exciting move. Great divide. Noticing that only in this last step did I need to change the direction of my symbol. My solution, x less than or equal to -5. Next one. What is the solution to this? All right. So first thing, let's go ahead and start distributing. Now I'll go ahead and start getting my x's together. Now I'll go ahead and do an exciting move. And of course, a great divide. And I end up with an answer of 17/2. Let me just verify that with an NSolve. .5, which would be 17/2. Perfect. Next one. Which graph best represents 2 multiplied by 5 to the power of x? Well, first thing, this is going to be my y-intercept, so it should be over here on my y-axis. It should be touching at approximately 2. This guy is definitely not. That guy's not. So this one maybe, this one maybe. My next point should be located at x equals 1. 2 times 5 is 10. So x equals 1. Should be here. Not it. It's 1. There we go. My graph is F. Next one. Scientists are studying a bacterial sample. The function gives the number of bacteria in the sample at the end of X days. Which statement is the best interpretation of one of the values of this function? The initial number of bacteria is 12. No, the initial number is 245. The initial number of bacteria decreases at a rate of 88% each day. They're not decreasing, they're increasing. The number of bacteria increases at a rate of 12%. That is consistent. The number of bacteria at the end of one day is 245. No, because if I plug in x equals 1, it will be higher than 245. My correct answer is H. All right, next one. Here they want me to go ahead and multiply this out, so I'm going to use my fancy box method. And of course, I'm just going to start multiplying in. Remembering that it's always diagonals that we'll need to combine. There's my simplified form. Next one. So here they're talking about a linear relationship, and they want to know the rate of change. Of course, we could totally run a linear regression and get this answer, but if we wanted to calculate it manually, we can as well. The rate of change is 2. Next one. The daily cost of hiring a plumber to work X hours on a repair project can be modeled using a linear function. The plumber charges a fixed cost of $80 plus an additional cost of $45 per hour, with a maximum of 8 hours. What is the range? So they want to know the y values depending on how many hours he works. So I have an equation, and I'm going to do a little bit of cheating here. I'm going to go ahead and I'm just going to graph this bad boy. Now I'm going to look at the table of values. This is going to plug in all of the information and give me exactly what I need. So if he works 0 hours, he's going to get that $80 just for showing up. 1 hour is $125. 2 hours, $170. 3 hours, $215. 4 hours, $260. 5 hours, $305. 6 hours at $350, 7 hours at $395, 8 hours at $440. But they told us his maximum was 8 hours. So we have all of these values. This is going to be a discrete function. Okay? All right, next one. We're almost done. Here they want us to go ahead and simplify this expression. So let's go ahead and get started on that. First thing I see is this guy. So I'm going to go ahead and start rewriting things. I see 10 over 2, that'll be 5. Q to the power of 5, W to the power of 4, multiplied by 4, W to the power of 5, Q to the power of 12. I'm going to keep simplifying. And I end up at my final answer. Pretty simple. All right, very last one, I believe. Yep. So what is the slope of the line that passes through these points? Of course, all I have to do is just start calculating my slope. So I'll go ahead and I can pick either one of these values, but I'll choose this guy because it has excuse me, I'll choose this one because it has my x values where it's positive. So 5 minus negative 9 over negative 11 minus 17. And I find out that my slope is negative 2. So that is everything to help you review for your semester final exam. I'll see you next time. Have a good rest of your day.